Have you ever wondered how the red planet Mars came into existence? Picture, if you will, a time approximately 4.6 billion years ago. The vast expanse of space was home to a colossal cloud of gas and dust. This was the solar nebula, an entity composed mainly of hydrogen and helium, the remnants of stars that had lived and died in previous generations. Now imagine a disturbance in this nebula. Perhaps it was a nearby supernova, the explosive death of a star, or maybe a celestial body just passing by. Whatever the cause, this disturbance was the catalyst that initiated a gravitational collapse within the nebula. Picture the cloud of gas and dust contracting, the particles within it drawn together by the ever-strengthening force of gravity. As the nebula collapsed in on itself, the center mass grew denser and hotter, until finally our sun ignited. This radiant star, burning bright with nuclear fusion, was more than just a new light in the cosmos. It was destined to become the gravitational focal point of our burgeoning solar system, the celestial anchor around which everything else would revolve. Yet the birth of the sun was not the end of the nebula's story. The leftover gas and dust continued to orbit the newborn star, the gravitational pull keeping it in check. Over time, this material began to form a rotating disk around the sun. But that's a tale for another time. For now, let's pause and marvel at the cosmic spectacle that unfolded billions of years ago. The birth of our sun, a stellar event in its own right, was but the first chapter in the grand narrative of our solar system's formation. It set the stage for the creation of the planets, moons, asteroids and comets that make up our cosmic neighborhood, including the intriguing world we know as Mars. And so, amidst the chaos of the cosmos, our sun was born, becoming the gravitational heart of our newly formed solar system. Now, with our sun at the center, a fascinating cosmic dance was about to begin. Picture a colossal rotating disk of gas, dust and rock, all swirling around the newborn sun. This is the protoplanetary disk, the stage upon which the planets of our solar system, including Mars, began their existence. The protoplanetary disk was a turbulent place with particles of all sizes buzzing around, colliding and often sticking together. This constant activity was fueled by the gravitational energy of the sun at the center and the mutual attraction of the particles themselves. Over time, these particles, some no larger than a grain of sand, began to come together to form larger and larger clumps of matter. These clumps, or planetesimals, were the first building blocks of the planets. Imagine a cosmic game of tag, where particles and planetesimals are constantly in motion, attracting each other, colliding and merging. It's a chaotic dance, but one that is guided by the universal laws of physics and gravity. In this cosmic dance, size matters. The larger a planetesimal becomes, the stronger its gravitational pull, attracting more and more particles and smaller planetesimals. But this dance wasn't always smooth. Sometimes collisions were so violent that they shattered the planetesimals into smaller pieces. However, these dramatic events did not halt the process of growth, but rather contributed to it. The fragments were recaptured by the gravitational pull of the larger planetesimals, eventually merging and growing into even larger bodies. Through these processes, over immense timescales, the planetesimals grew in size, eventually reaching the stage known as protoplanets. Mars was one of these protoplanets, a world in the making within the dynamic protoplanetary disk. So the birth of Mars, and indeed all planets, is a story of growth and transformation, of tiny particles coming together to form larger bodies, of violent collisions and peaceful mergers. It's a tale that takes us back billions of years to a time when our solar system was just beginning to take shape. These tiny dust grains and larger objects were the first building blocks of the planets, including Mars. In this cosmic nursery, Mars began its journey as a protoplanet. A tiny speck of matter in the grand scheme of the cosmos, Mars was destined for a journey filled with challenges and transformations. The process of accretion was one of the first steps in its development. Mars, like a cosmic sponge, absorbed the surrounding material. Tiny particles and planetesimals, the building blocks of planets, swirled around in the protoplanetary disk. Influenced by the invisible hands of gravity, these particles collided and merged. Each collision, each merger was a small step towards the growth of Mars. Over immense timescales, these tiny increments added up, and the protoplanet began to take shape. Yet the journey of a protoplanet is not a smooth one. Mars faced numerous challenges as it moved through the protoplanetary disk. Collisions were a significant part of its growth, but they were also a source of peril. Some collisions were gentle, akin to a cosmic caress. Others were cataclysmic, events of such magnitude that they shaped the destiny of the protoplanet. The heat from these collisions was intense, a fiery crucible that transformed the protoplanet. Added to this was the heat from the young sun, a radiant beacon in the center of the solar system. The combination of these heat sources led to a fundamental phase in the development of Mars: differentiation. The intense heat caused the materials within the protoplanet to separate based on their density. Heavier elements like iron and nickel migrated towards the center, forming the core of Mars. The lighter elements and compounds composed the outer layers. This process of differentiation was critical in setting the stage for the unique composition and structure of Mars. Through trials of fire and collision, Mars was taking shape, its destiny being written in the stars. Each challenge faced, each transformation undergone, was a step towards becoming the Mars we know today, a planet of red hues, towering volcanoes, and fascinating geological features. As Mars grew, it underwent a fundamental transformation known as differentiation. Imagine a bustling city with people moving around, finding their place in the world. Now, picture the same scenario, but on a planetary scale. Differentiation is the process where heavier elements, like iron and nickel, migrated towards the center of Mars, forming the core. On the other hand, lighter elements and compounds composed the outer layers. This process, like people settling down in a city, set the stage for the unique composition and structure of Mars. The differentiation process isn't a stroll in the park, though. It's more akin to an intense workout session. The heat generated from the collisions of particles and the young sun's heat played crucial roles in driving this process. It's a fiery, chaotic, and essential phase in the formation of any planet, including our own Mars. But the universe had more in store for Mars. As it continued to grow, Mars entered a phase known as the Late Heavy Bombardment. This period, as dramatic as it sounds, was characterized by intense asteroid and comet impacts. It was like a cosmic hailstorm that left a lasting impression on many bodies in the inner solar system, including Mars. The late heavy bombardment was not just a destructive phase, it was also a time of creation and transformation. The impacts from asteroids and comets shaped the surface features of Mars, contributing to the planet's geological diversity. The craters, valleys, and mountains we see on Mars today are the remnants of this intense period. These cosmic collisions and internal transformations were like a chisel and hammer, sculpting Mars into the planet we know today. Each impact, each internal shift, made a mark on the canvas of Mars, painting a picture of a vibrant and dynamic world. The story of Mars is a testament to the power of change, the ability to adapt and evolve, and the beauty that can arise from chaos. These cosmic collisions and internal transformations were the chisel and hammer that sculpted Mars into the planet we know today. But Mars' journey didn't end there. The planet continued to evolve and transform. After the late heavy bombardment period, the planet's surface bore witness to a new era of transformation, marked by the powerful forces of volcanic activity. This was a pivotal chapter in the red planet's evolution. Mars's surface is a testament to this age-old volcanic activity, with vast plains and towering shield volcanoes serving as silent reminders of a fiery past. Among these volcanic giants, Olympus Mons holds a special place. This colossal shield volcano, the largest in the solar system, stands as a monumental testament to Mars's tumultuous geological history. Yet it's not just the colossal volcanoes that make Mars stand out in the cosmic crowd. The planet's distinctive red color, a feature that has earned it the moniker the Red Planet, is another intriguing facet of its story. This unique hue arises from the prevalence of iron oxide or rust on its surface. Over eons, the interaction of iron-bearing minerals with the Martian atmosphere has given birth to these reddish hues, painting a captivating portrait of a world unlike any other. However, the story of Mars does not end here. Even today, the planet continues to evolve, its geological narrative being written with each passing moment. Eons of cosmic weathering, atmospheric dynamics, and subtle geological processes continue to shape the Martian landscape. These ongoing transformations not only provide us with a deeper understanding of Mars' past, but also offer valuable insights into its potential future. So what's the take-home message from this celestial tale? The story of Mars's formation and evolution is a testament to the intricate dance of cosmic forces that shape our solar system. From a protoplanet in the cosmic nursery to the captivating red.
Have you ever pondered the birth of Mars and its connection to the creation of our solar system? To answer, we must journey back in time, approximately 4.6 billion years, to a colossal cloud of gas and dust known as the solar nebula. This nebula, a cosmic concoction of hydrogen and helium, was disturbed by a supernova or passing celestial body, leading to a gravitational collapse and the birth of our sun. Thus began the story of our solar system, with our radiant sun at its gravitational heart. As the sun took shape, the surrounding nebula transformed into a rotating protoplanetary disk. Within this disk, matter coalesced into planetesimals, the building blocks of planets. Among them, Mars began to form. Mars, a fledgling protoplanet, grew through the gradual accretion of dust and larger bodies. This process, driven by gravity and mutual attraction, dictated the growth of Mars over unimaginable timescales. But it wasn't a smooth ride. Collisions shaped Mars, while the heat from these impacts and the young sun led to differentiation, a process that separated materials based on their density. Heavier elements sank to form the core, while lighter elements composed the outer layers, crafting the unique composition and structure of Mars. As Mars matured, it endured the late heavy bombardment, a period of intense asteroid and comet impacts. These cosmic collisions left indelible marks on the planet, shaping its surface and contributing to its geological diversity. Volcanic activity also played a significant role in Mars' evolution. The planet's surface bears the scars of ancient eruptions, seen in its vast plains and towering volcanoes. Olympus Mons, the largest volcano in our solar system, stands as a testament to Mars's tumultuous geological past. The distinctive red hue of Mars, from which it derives its moniker, the Red Planet, is the result of iron oxide or rust on its surface. This interaction between iron-bearing minerals and the Martian atmosphere has painted the planet in shades of red, capturing the fascination of astronomers and space enthusiasts. Mars, however, is not a static world. It continues to evolve, shaped by eons of cosmic weathering, atmospheric dynamics, and geological processes. The ongoing transformation of this intriguing planet is a testament to the complex